Okay, good day. Today, let's take a look at your saliva and the digestion. Okay, of course, you already know that your digestion, that is the disintegration of naturally occurring foodstuff into their absorbable forms of, and yes, your digestion involves both mechanical and chemical processes. Okay, and so yes, let's take a look at your saliva. Your saliva, this is a clear liquid made, of course, by your saliva. Okay, so what is the purpose of this one? Is it will provide, okay, and so lubrication. It will lubricate the food to provide a consistency that is suitable for swallowing. And yes, your saliva also is capable of performing chemical digestion. Okay, and so how is that? So please note that your saliva contains salivary amylase and a small amount of lingual lipase accordingly that can digest or that can hydrolyze, that can uh, speed up the process of hydrolysis of carbohydrates. And yes, okay, and so it will hydrate your oral cavity. With that, it will contribute to your oral hygiene accordingly. Okay, and so that is for your saliva. Moving on, your saliva, that is your saliva. There are two key cells in your salivary glands. You have your mucus cells and your serous cells. Okay, and so for your mucus cells, of course, they will secrete a glycoprotein-rich saliva. While for your serous cells, they secrete an enzyme-rich saliva and a lesser viscosity, a watery secretion. Okay, and so that is for mucus cells and your serous cells. And again, your salivary glands, they are made of mucus cells and or serous cells accordingly. Okay, and so yes, in your mucus cells, it secretes a glycoprotein-rich saliva. You have this mucin. Okay, and so that is the key component of your mucus cell secretion. Okay, and so yes, moving on. Let's take a look at your salivary glands. Accordingly, you have your intrinsic and your extrinsic salivary glands. Your extrinsic salivary glands, these are otherwise known as your major salivary glands. For your intrinsic, these are otherwise known as your minor ones. Okay, and so your intrinsic salivary glands secretes a saliva at a constant rate. Okay, and so at a constant rate, and that accounts for 10% of your total saliva. Okay, and so enough is secreted to moisten your buccal cavity. Okay, and so for that one. Okay, and so please note that these intrinsic salivary glands are the buccal, your labial, and your palatine. And yes, they are located inside the buccal cavity. Comparing it with your extrinsic, they are located outside. Okay, and so they secrete saliva based on stimulus. Okay, and so what is the stimulus? Of course, the presence of your food in the mouth. Okay, and so the thought of food, the smell of food. Okay, and so those items accordingly. Okay, and so and yes, they secrete 90% of your total saliva. Okay, and so that is for your saliva, your extrinsic salivary glands. No, okay, and so please note that you have here your major glands. They are your parotid gland, which is made of serous cells, more serous cells, your sublingual, more mucus cells accordingly, and your submandibular. This is a mixture of your serous and mucus cells accordingly. Okay, and so for your intrinsic salivary glands, you have here the presence, the predominance of mucus cells. Okay. Yes, of course. And so you already know your saliva. Okay, and so let's take a look at its components accordingly. Okay, and so your saliva contains mucin, salivary amylase or your thiolin, your urea, your glucose, lactic acid, phosphatase, and carbonic anhydrase among its contents. No? Okay, and so yes. Okay, and so let's prepare your mucin. Okay, and so that will be utilized in the following procedures. Okay, and so you need to have a 10 ml. Of course, you need to collect 10 ml of saliva. And then after that, you add 30 ml of 95% cold ethanol. Okay, and so you let it stand until a whitish mucoid precipitate is formed. And yes, after that, you of course, you save the precipitate. Ang kailangan lang po natin is the mucoid precipitate. Okay, and so you can discard the supernatant. Okay, and so of course, yes, you divide this one. You divide the precipitate into, uh, yes, you divide it into four. Okay, and so since we have four tests for your organic components, organic constituent of saliva, okay, and so one will be for the urette test. Okay, and so you need a precipitate plus 10 drops of sodium hydroxide and then add 20 drops of 1% copper sulfate. Of course, after that, you observe the color produced. Okay, and so that is for the red test. Again, hypothetically or theoretically, you have here the presence of your mucin, your thiolin, your urea, your glucose, your lactic acid, your phosphatase, and the rest. Again, your mucin, that is a glycoprotein. Okay, and so moving on, let's take a look at the other test. You have your Milon's test. This one. Okay, and so you need the precipitate plus 10 drops of Milon's reagent and then heat in a water bath until a distinct color is observed accordingly. Of course, you note the color and yes, you record the observation. Moving on, let's take a look at the other test. Okay, and so you have your Molish test, your precipitate, and then add 10 drops of Molish reagent and then gently mix use by swirling. And then after that, you incline the tube and carefully add 30 drops of concentrated sulfuric acid on the side of the tube so that two layers are formed. Again, please note that sulfuric acid is corrosive. Okay, and so it can burn your skin. And then, of course, after that, you observe the color that is produced. Okay. And yes, finally, for your Benedict's test, this is the last test that will be done in testing the organic contents of saliva. Okay, and so you have your precipitate, of course, plus your 1 ml Benedict's reagent, and then you heat in a boiling water bath for 3 to 5 minutes. Okay, and so and observe for the color produced. Okay, and so again, theoretically, you have the your organic matter present in your saliva, you have your mucin, your thiolin, and the rest. Okay, and so yes, let's take a look. For your burette test, of course, this one is a test to detecting the presence of two peptide bonds. Okay, and so for your test to be positive, the sample should contain at least two peptide bonds. And the positive result for this is purple. Okay, and so again, theoretically, your saliva contains a glycoprotein mucin. And again, theoretically, it should give a positive test. Okay, and so since the glycoprotein, the protein that is present in your mucin, has more than two peptide bonds. Okay, moving on for your Molish test. This one is a general test for carbohydrates. And yes, okay, and so you have a glycoprotein again. Your sample is a mucin clot. mucin precipitate. Then theoretically, it should give a positive result. And what is the positive test for this? You have a purple ring at the junction, a production of purple ring at the junction of the test, of the sample, sorry. Okay, and so moving on to your Milon's test, you have here, it will detect the phenol group in tyrosine, of course, again. And so you have a positive test of red or pink precipitate. Okay, and so and moving on your Benedict's test, you're reducing proper, it will test for the reducing property of your sugar, and the positive result for this one is your brick red precipitate. Okay, so a brick red precipitate for this one. Accordingly, and so going back into your organic components of saliva, you have glucose as a part of it, and glucose is a reducing sugar. Okay, and so that is why presence of glucose will give you brick red precipitates. Okay, and so theoretically, yes, moving on, your saliva, please note that you have here your activators of your saliva. You have your chloride, your bromide, your iodide, and nitrate. Okay, and so your iodine again and your nitrate here, they activate your salivary amylase at a lesser extent. Okay, and so what is the function of your mucin? It will protect and lubricate the surfaces. Okay, and so it will protect your mucous membranes. Okay, and so and will lubricate also the surfaces. Okay, and so allowing for a better flow of your food. Okay, and so passage of your food. Okay, thiocyanate. This one accordingly is formed in the decomposition of your cyanide. And yes, thiocyanate can be used as a biomarker for the exposure to cyanides or cyanide releasing chemicals like smoking. Okay, and so it is a can be used as a biomarker. And yes, please note that your salivary amylase, that is the key component of saliva that is needed in chemical digestion of carbohydrates. Okay, let's move on and take a look at the test for, or let's move on and take a look at the inorganic constituents of saliva. Okay, and so how are we going to prepare our sample here? Pa rin, kailangan po natin ng saliva. We still need saliva here. Okay, and so you need 10 ml of saliva and acidify this one. Place it in a test tube and then acidify with nitric acid. Okay, and so how are you going to know if naging acid na po siya? Okay, and so you need at least a blue litmus paper. Okay, and so the blue litmus paper should turn into red. Okay, and so yes, you heat the boiling, and then after that, you filter. You save the filtrate. You discard the precipitate. Okay, and yes, this time we will be needing your filtrate. Moving on, let's take a look at your test. Okay, and so you will be taking a look at your theoretically again for your inorganic constituents of your saliva. You have fluoride, bicarbonate, sodium, potassium, calcium, sulfate, phosphates. These are present accordingly in your saliva. Okay, so yes, let's take a look at your chloride. For this one, your reagent, you need 2 drops of nitric acid, 1 ml of filtrate, and then add 2 drops of nitric acid. Then after that, you add 2 drops of silver nitrate and then observe for color or precipitates that is formed. Okay, and then next, you test for the presence of your sulfate. 1 ml of filtrate and then add 2 drops of concentrated hydrochloric acid. After that, you add 10 drops of barium chloride solution and then you observe for the color or precipitates produced. Okay, and so that is for your sulfate. Next, you need again a new set, a new sample. Okay, so one filtrate, place it in a test tube, and then add 10 drops of ammonium oxalate. And yes, you know the color, the formation, sorry, of your precipitate. If precipitates formed, okay, and so then probably you have calcium ion. So moving on, your nitrite, you need 1 ml of filtrate and then add 5 drops of sulfuric acid. Then after that, you add 5 drops of potassium iodide solution and 5 drops of starch solution. And then, yes, mix thoroughly and then note the color that is formed. Okay, and finally, for your thiocyanates, you need 1 ml of filtrate and 5 drops of ferric chloride solution. After that, you acidify with 2 drops of concentrated hydrochloric acid, and then you note or observe the color that is produced. Okay, sorry, meron pa pala, phosphates. You need 1 ml of filtrate and 10 drops of ammonium molybdate, and you observe for the changes in the color. Okay, and so finally, let's take a look. Please note that for your thiocyanate, a positive test will give you a red complex if this one is present. Okay, and so if thiocyanate is present, a red complex is formed. If nitrite is present, brown color is formed. Brown color will be observed. If chloride is present in the saliva sample, white precipitates should be recorded. Sulfate, the presence of sulfate in the saliva is indicated by white precipitate. The presence of calcium in a saliva is indicated also by a white precipitates. And the presence of phosphates in your saliva in your sample is indicated by a bright yellow precipitates. Okay, and so that is for your inorganic constituents of your saliva. Again, and so theoretically, you have carbonate, sodium, potassium, calcium, sulfate, and phosphates in the saliva. Okay. And so, yes, let's take a look at your digestion by your salivary amylase. Okay. And so first, what we did is we tested the reducing property of starch. And yes, your starch is not a reducing sugar. Okay. And so it is a polysaccharide. Okay, and accordingly, it is not a reducing sugar. How are you going to test for the Benedict's test? You need 1 ml of 10% starch solution plus 1 ml of Benedict's solution. Okay, and so mix and then heat in a water bath for 5 minutes. Boiling water bath for 5 minutes. Of course, starch again is not a reducing sugar. That is why it should not give you a brick red precipitate. Okay, again, it should not give you a brick red precipitate. A blue color that is imparted by the Benedict solution is a negative result. And that is the expected for your starch. Moving on. Okay, and so digestion by your salivary amylase accordingly. And so based on the manual that was given. Okay, and so you need here a mixture of saliva and a mixture of your saliva and starch, 10% starch. Okay, and so accordingly. Okay, and so first, before you heat, sabi niya in your manual is you need to test. Okay, and so need to test for iodine test. And it should give you a positive test. Again, it should give you a positive test. Okay. And so because accordingly, okay, and so in your starch, your iodine, okay, and so will fill the interstices of your starch. Okay, and so yes, your iodine will give a purple color. Okay, and so during this one, okay, and so because your iodine will interact with starch, giving you a blue-black coloration. If wala pong blue-black, there should be at least a precipitates, black precipitates that is formed. Okay, and so please note that the iodine molecule present, the iodine molecule that you added in your solution will fit into the helical structure of your amylose that is present or component of your starch, forming a complex, okay, and so that absorbs light differently and produces this characteristic color change. Okay, and so a positive test, you have a blue-black again, or a blue-black color or brown or black precipitates for this. Okay, and so you heat. Please note again, going back into your salivary digestion. For this one, in your salivary digestion, your salivary amylase cannot digest a carbohydrates, a polysaccharide to produce individual glucose units. Ang kaya niya lang po until maltose. It cannot digest maltose to produce individual glucose units. Okay, and so we'll give you limit dextrin and then maltose. Okay, and so the final end product of salivary amylase digestion should be maltose, maltose lang. Okay, and so again, it cannot digest a polysaccharide to produce individual glucose units. Maltose lang po. Okay, and so yes, of course, and so it will give you a positive test for iodine test again, and so you still have the dextrin, okay, and so present for this one that will give you a positive test for iodine test. Okay, and so of course, uh as you expose it longer as you expose your solution, as you expose the starch into the enzyme, okay, and so it will further digest the starch. Okay, and so it will further digest your starch. Okay, and so the idea here in the digestion of your starch is that the longer the time, okay, and so the longer the time as the time goes by, the iodine test, okay, and so the tubes will get a negative test. Okay, and so as it goes by, the tube should get a negative iodine test. Ganun po dapat. Okay, and so again, as the time goes by, okay, and so the tube should get a negative test. Okay, and so by the time na nakapag-produce na po siya ng maltose, okay, and so maltose is not anymore positive for iodine test. Okay, and so ganun po. Ganun po dapat. Okay, and so that is for digestion by salivary amylase. No? Okay, and so moving on, if that happen, there is no anymore, there is a negative test for iodine test, then that is the time that you will perform. Okay, and so your digestion is already complete. You already produced, theoretically, you already produced maltose. And again, maltose is not it will not give a positive test for iodine test. Okay, and yes, sabi niya in the manual is after it gave a negative iodine test, then that is the time that you will test for its reducing property, for the reducing sugar. Please note that maltose is a reducing sugar. Okay, and so how are you going to do that? 1 ml of solution from the digestion tube and add drops of sodium hydroxide until the red litmus paper becomes blue. Okay, and so from this sample, from this sample, you get 1 ml and add 1 ml of Benedict solution. And then after that, you had in a boiling water bath for 5 minutes. Okay, and so the expected result should be a brick red precipitate. Because again, the end, I mean, uh, your salivary amylase. Okay, and so the end of the digestion should be maltose units. Okay, and so it should be maltose units, and your maltose, this is a reducing sugar. Okay, and so that is for your digestion.